So let's have a look at how we calculate the concentration in terms of parts per million or parts per billion. So by the end of this, you want to be able to perform those calculations, and we'll know you can when you can do it independently. So parts per million is where we'll start. This is used to measure very dilute concentrations, so magnesium chloride in drinking water or carbon dioxide in the air. So it's different for solutions in liquid, that's measured in mass. If we're talking about solutions in gas, like the air, we measure it in volume. So liquid is done like this. It's concentration, parts per million, equals the mass of the solute in milligrams. So whatever mass you have, you need to convert that to milligrams, divided by the mass of the solution in kilograms. So whatever mass you have there, you need to turn that into kilograms. The gas, okay, so concentration in parts per million, we go from the volume of the solute in milliliters, and we divide that by the volume of solution in kiloliters, which is something we don't often use. So remember that. We've got to go from, so it's milliliters divided by kiloliters, or milligrams divided by kilograms. Now liquids, let's have a look how this works. The first thing I want you to pay attention to when these numbers pop up is I want you to look at the changes in order of magnitude that we have to make. So concentration is parts per million of parts per million equals mass of the solute, milligrams, divided by mass of the solution in kilograms. What we have here is we have 0.0537 grams of magnesium chloride is found per 250 grams of solution. So we want to find the concentration in parts per million. Now, again, what we're talking about difference in the orders of magnitude is this one is in grams and this was in grams, and that means we're going to need to make a shift to change that. So the way this works is this, right? So we go mass of the solute divided by mass of the solution. Now 0.0537 grams is 53.7 milligrams. 250.0 grams is 0.2500 kilograms. So we do this little change for our orders of magnitude, and we go, and we divide it by each other, and our concentration here is 215 parts per million. And that's it, and it's the same thing with volume as well. So let's have a quick look at parts per billion. Our goal is to keep these short, so that's why we'll stick with the 1, and you can change from liters to grams easily. In parts per billion, if measurements are made in micrograms or microliters instead of milligrams or milliliters, then the calculation is parts per billion. So if I measure that instead of being 530 or 53.7 milligrams, then that might actually be 53.7 would be 53,700 micrograms divided by kilograms, and that'll tell us how many parts per billion we have. So parts per billion is actually used for even more dilute concentrations. Alright, hope that made sense. Thanks for paying attention, and if you have any questions, put them in the comments below and we'll get back to you as quick as we can. Thanks for watching. Bye now.